my home screen right now? There we go. You need a smart notebook open really quickly. Okay. Where did we get stuck on number 3? Slope of a tangent, equation of a tangent line. Should that one have been bad? Not too bad. You have an x, how do you find a y for y minus y1? They gave you the point. Steal the y, right? Because this is the graph of f of looking at. How do you find the slope? Derive the function. Plug in 1. Do not use e to the 2x as a slope. You must have a number as a slope. If you have an x times an x, that is no longer a line. A quadratic, a cubic, an exponential, who knows what you have. But if you keep an x here, you just mess up your line. You must plug in 1. Star.
Okay, I did something. I didn't do the x out of 1. I used the y minus y1 equals x times x1.
Yeah, y minus y1 equals m times x minus x1. So technically, I would have even told you guys not to do that because I saw someone after school yesterday try to do something similar. Don't even ask. I don't know. Everything is weirder and weirder. But they made a mistake moving it over. I told you guys sometimes it'll happen. This is someone who doesn't usually make mistakes. So y minus y1 would be your e squared equals f prime of 1 is your m, and then x minus 1. That's not enough to box because you don't have an answer for f prime of 1. If you take the derivative of f, e to the u times u prime, you get 2 e to the 2x, but you have to plug in 2 e to the 2 times 1. You have to plug in the x1 into the derivative as well. Does that make sense, sir? Box that. They do not say for a tangent line you have to get y by itself.
I got.
Oh, cool.
I
I thought you were using it.
I was just wondering if that was like.
That form is good?
Yeah.
That form is great. You do not have to go back.
Right. So a lot of the time they'll give you like a function and then they'll say find a particular solution of y equals f of x. When it says y equals f of x,
You
have
must
to
get
find
y by itself.
Okay.
Eventually. It doesn't have to be right away. You could get c first and then get y by itself, or get y by itself and get c.
Okay.
Okay. Once it said find the area of R. Kiddos, looking at the region of R, does top bottom make more sense or right left? Both are possible. Top bottom makes more sense to me as well. Top bottom. What's on top? Your curve. What's on bottom? Y equals 0. Top bottom, is that in terms of x or in terms of y? In terms of x, because top bottom is always in terms of x for every cards, right? So we need x bounds, which would be 0 to 1. We need our top curve, which is e to the 2x in terms of x, perfect, minus 0. Dun, 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 dun. Area, just top minus bottom. When do we start having to do pi r squared and s squared and all that sort of weird stuff? That's when we're doing volume. Just a couple of you, it might be, and I haven't actually looked at the one I'm ending up giving you. It might come up that they might ask you equilateral or isosceles for cross section. This is random getting into volume. It's every now and then, and it's one random question. So if you guys do want to study those area formulas tonight, that's one thing that we didn't put in our forever cards that we'll probably put in next week on our cross section card, just because it does show up every now and then. It's kind of done though. Letter C. Speaking of volume, what's going on there? Are perpendicular to the
y.
Do we have a choice if it's perpendicular to the y-axis as to whether dx or dy?
Nope.
No. We must do dy. So if we must do dy, then we have to go right left. Now, what shape? Squares. Brandon, do you have a question, Ben?
What are the formulas in particular that you square the insides, like on C? Do you see how
When you're doing volumes, we take integral of area formulas.
Okay.
If there is a rotation, a revolution, revolved about, rotated about, that's going to be pi r squared.
Okay.
It could be disc or washer.
Oh.
That's why I did cross sections first and then, because it's circular cross sections.
Okay.
Yeah. And that comes in with the funnel problem in 2016. I don't know if you've gotten that yet. For the circular cross sections, you need pi r squared. For squares, volume, cross section squares, you need s squared. For semicircles, 1/2 pi r squared. Watch out. R is not the top minus bottom or right minus left. Diameter is. If you cut it in half, then plug it in. Quarter circles, 1/4 pi r squared. Rectangles, base times height, they have to give you a clue for the height to plug in. Then I mentioned the equilateral or the isosceles, but that's when it's volume. Area is just top, bottom, or right, left. So with the volume, guys, we have squares, which is y. As Brandon pointed out, we have side squared. Everything is in terms of y. How'd they get that? Solve for x. Solve for x, get the function in terms of y. As we're going right minus left, how did they get this weird 1 plus thingamabob? Yeah, I have no idea if this is going to actually write. Oh, hey, it does write for here. Right minus left, I do have x equals 1 being here. The right, 1 minus, and the left, once you solve for x, you do end up with ln of y over 2. It's sad I have that memorized. Anyway, 1 minus ln of 2 is perfect right left until you get to right here. It stops. I have to split up the integral into another integral from 0 to 1 of 1 minus 0. Wait, isn't that just a rectangle? Oh, it's a rectangle with a base of 1 and a height of
1.
So I can say rectangle, area 1 plus the rest. That's what they did. They did the cheater, short and simple. But could you have also done the integral from 0 to 1 of 1 minus 0 squared dy instead of 1? Yes, it would have also been. Does that answer it?
That graph is not scale. The
No.
ones are not
Well,
distance.
X's and Y's are not equidistant. You have to keep an eye out. Are there any other FRQ or FRQ parts you guys want to see particularly? Yeah, Bridget.
Number 4.
On this same one? D?
Yeah.
Okay.
I know we're using FTC part 2, but I don't know what. I can go to D now.
Okay. Well, the first thing for letter D to think about, guys, chain rule, right? They give you an H, you have to take a derivative and then plug in 1. All of you guys were like, I'll plug in 1 first. That means it's a number, and the derivative of any number is 0. You never plug in until you derive. So to take the derivative, guys, how does chain rule work? G prime, keep the inside, times 3x squared. So the question was, well, how do we get G prime? Because we had to plug in. So down here in the answer key, this was just simple chain rule. Then it was time to plug in 1, which they did right here. But the question was, how do I get G prime of 2? Now, earlier in the question, you had to figure out G prime of x, which looks nice and short and simple right here, 2 plus f of x, but it all comes back to taking the derivative of the expression. The derivative of 2x is 2. The derivative of an integral, ftc part 2. The derivative of an integral from a to x of f of t dt is just f of x. Times u prime is just 1, because it's just an x. So I can change g prime of 2 to be 2 plus f of 2. That's what g prime of x equals with 2 as x plugged in. How do I find f of 2? What kind of value is that? Looking at a graph of f, of y equals f of x. Yeah, okay. Go. Okay, how do you find f of 2 using the graph? Go to 2, find the y now. So steal the 3. F of 2, whenever you have a graph, it might help you to write y equals f of x.
Well, because I got, after I did G prime of 2 plus f of x, I got 2 plus f of 3. And that's when I got stuck, because I didn't know what to do. Or why I got 3.
G prime of 2 is 2 plus f of 2. And f of 2 equals 3. So then you get 2 plus 3 times 3. You can just box that in. They did 2 plus 3 is 5. 5 times 3 is 15.
What is
F of 2, remember, look at your graph. At 2 was the y value, 3. So the f of 2 comes out, the 3 goes in.
so my answer for the thing is
2 plus 3, parentheses, times 3, box it. You're good. Katrina, what was your question?
Does the increase, which one do they say is FTC and FTC part two. It's the same way that we did it.
In the same way that we do it. But I don't really see them state it much. It's more of just to do it. But from what I have seen, they call it maybe. Yeah. 5C? Of the same one, right?
Yeah.
Okay. Number 5 is the particle on X, particle on Y. Can I give you guys a quick picture for this real fast? Doesn't it say X, Y axis? Particle X is moving. I have no idea if I can make this work. That's where X is moving. In letter C, something else is moving now. Oh, no. Particle Y is moving. And they say, hey, with particle, whenever you have a part in a question, it doesn't mean the rest doesn't still apply. We still have X moving. And they say, hey, there's another particle moving this way. And then it says, hey, this makes a triangle with the vertices being in the first quadrant. So I know I don't know how else you would draw a triangle not in the first quadrant, but either way, that's okay. You guys see your triangle? So if you draw X going on the positive X axis and Y going on the positive Y axis, then hopefully that triangle makes a little bit more sense. And if they start talking about rate of change of the, you guys figure out the area? Rate of change, doesn't that mean I need to do some sort of DDT? Right? Of what area? Well, okay, hold on. What's area of the triangle? Yes, but I don't want to keep base and I don't want to keep height. I want to make it something that I can refer to with all my information. So who is the base? X's position. Who is the height? Y's position. So I can say, instead of just that, I can say A is equal to 1/2 X times Y. And then they say, as soon as I see rate, I can say, sweet, it's time to take it to rate. Classic, related rates. You have a shape, think of a formula, get it in terms of the variables at play or being used. So then, kiddos, how do I take the derivative with respect to t of all of this stuff? What's the derivative of A? 1 dA dt. Hey, isn't that the rate of change of area? Which I'm supposed to find. Equals, here's the most common mistake. Do you guys see the product rule? Okay. Second G first, you guys figure out you need dx dt because it's with respect to another variable. And then I need x times dy dt. Right? But the problem is, what do they tell me as far as plugging in? X's and y's? T. How do I plug in t equals 1 to what they give me about x at the very beginning? What they give me about y in part C? Can I plug in 1 and get an x?
Yeah.
Can I plug in 1 and get a y? What about dx dt and dy? Can I find x prime and plug in 1? Can I find y prime and plug in 1? Simple and done. After you do each of the steps. So some people would have gotten stuck with the picture. Some people would have gotten stuck with what's base, what's height. Picture helps. Some people would have gotten stuck with the product rule. Some people would have gotten stuck with how to plug in. X was in the original. Y came in later. Remember, just because it's a later part of the problem doesn't mean the earlier part doesn't still apply and need to be used. You start.
So at the end, is this no calculator, right? Okay. So
Yeah, this is no calculator.
I got
But-
once I plugged in, I got like a bunch of numbers.
Yeah, and that's not bad. I would technically, right here, if I were you, because this is your, is that Y? Okay. That's your Y and your X prime. That's your X and your Y prime. I would just put in a little 1, a little 1, a little 1, a little 1, a little 1. Ha 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 ha! Stop. Do not simplify, but put in 1. Put in 1 and then just be like, forget it. I get it right. Right.
Can we look at 2016?
Yes.
Question 3, letter C.
If you guys haven't done it, you can come look at it. Ooh,
I did some
this looks awful familiar.
fuzzy math.
Fuzzy math. Letter C?
Yeah.
You can use fuzzy math, but since they're asking, like in general, to prove where an absolute min or max happens, you can visualize the area above, area below, and use like a paragraph to describe which one's higher and lower because of the area you see in ambiguous terms. Usually though, if possible, and especially if they're asking you to find the value itself anyway, you may as well just plug into a table and solve each one. So, each one meaning, kiddos, steps for finding absolute extrema. Who are we supposed to find for G? Just looking at this question, ignoring the rest of the blah, blah, blah. G prime equal to 0, critical numbers and endpoints. Now, in the critical numbers, technically, for absolute mins and absolute maxes, don't we really just want the relative mins and relative maxes to hump? Do we care about the non-relative mins and maxes that are critical numbers that didn't make the cut? So in that way, we would want to test, not even close, -4, 12, because those are the endpoints. And then, if you guys look at this, FTC part 2, just like the other one, FTC part 2, to find G prime, take the derivative of the integral, bless you, there's not even an extra piece. The derivative of the integral would be f of x, so we can say f is G prime. So we can think about this as the graph of the derivative of G, which means to find the critical points, all I need to do is find the zeros, right? How many are there? Let's test all of them. No. Which ones are relative extrema? Yeah, where it changes, where it, meaning the derivative, where f or G prime changes from below to above, or above to below. I don't need to worry about the ones where it's like, oh, maybe, oh, just kidding. Oh, maybe, oh, just kidding. Because the derivative goes from positive to positive, negative to negative. There's no relative min or max there. So the AP would say, don't even stress about 2 or 10. You could and do more work. Or you could forget 2 and forget 10. Just test these 4. And how do you test these 4? Plug them in to where? For absolute extremity. You're plugging in to the original. Who's the original for what we're trying to find? G. So we're going to plug each of these into G. Guys, how do we solve integrals when we just have a graph? Oh, and they're all geometric shapes. Area. You're going to have to find area. So, to find area, under the curve, the bound starts at 2. In order to go from 2 back to -4, if I can actually make it there, silly matters. To go from 2 to -4, to go this direction. Do you guys see the area I'm going to have to find? Big triangle, little triangle. But since I'm moving backwards, this area is going to be a negative number. This area is going to be a positive number. Moving backwards, the bounds would have to flip, and negative would have to be incorporated. So then we would end up with, can I find these areas real fast? This one is a base of 2, and that, no, a base of 4, height of 4 at 16, but then how many? This one's an area of 8. This one's an area, I think it's half of that, right? 4. This one's an area of 8. This one's an area of below 8. That's technically -4. And this one's -4 also, I think.
Yeah.
They're pretty symmetric in the sense that this one's half of that one, and then that one's half of that. So in order to go from 2 back to -4, I'm going to go 8 minus 4 is 4, but make it a negative. Hence, down here, -4 is -4. To go from 2 to -2, I just go back 8, so -8. I'm testing all my candidates. To go from 2 to 6, that's going to be a positive 8, and to go from 2 to 12, that's going to be a positive 8, -8, that's 0, -4. So they went ahead and used these areas to be able to fill in their chart and say, hey, endpoints, the relative extrema, who wins? I would like you guys not only to write the table, but say something to the effect of, at -2 is the absolute min value of -8. You had to give the -8, they asked for the value. -8 is the absolute min value. and positive 8 is the absolute max value, since those are the lowest and highest respectively of the candidates for absolute extrema. Something to that effect. If you can state critical numbers and endpoints, it's even better. They say they take the table as enough proof. I've seen older FRQs, they want more detail. Any other questions on FRQs? 2016 or the old ones? Yeah, on the old ones or the, yeah. It's not really that old, I just mean like the other one. You said 5C or 6C? Do you guys like drawing your baby's little field?
Yeah.
It's pretty close right there, right? Just plug in, get a number, make a baby tangent. They were kind of excited when they had it last year. At least Georgie was. Letter C, find the particular solution. This is the one Ryan was saying earlier. Oh, do you guys see how many points this puppy's worth?
Yeah, that would be really angry.
I warned you though, didn't I? These questions where they give you a differential equation and they say to solve for y equals not to use, not to find using. When they say to solve for the particular solution of a differential equation where y equals f of x, it's going to be worth 6 to 7 to 8. I've seen it be 8 points. But, do you guys see that you get nothing out of any of the points? It's an automatic disqualification if you don't start correctly. So start correctly. How do you separate legally? Multiply dx. I've taught you well. Follow what I've taught. Multiply the dx. So as soon as you multiply the dx, who no longer belongs?
The 1 minus 1.
Get him over. Now you can start getting points. That's a point, and you'll start getting points for anything.
It might be wrong if you did 1 over minus.
Oh no, not at all. Not at all.
Okay.
1 over y minus 1 dy is kind of easier for you to think ln.
Okay.
The one thing I want to say though is, guys, don't they make this jump look so easy? What if it was 1 minus y? Could you have jumped there?
Yeah.
Do your u and du. This one, u is y minus 1, du is 1, so it doesn't offset. But if this was 2y minus 1 or y minus y, do your u sub, or at least think about it, because they're going to try and get you almost always by throwing something in that needs a u sub. Because when it's integrating, guys, if you see something in the denominator, common mistake, this is not ln. Why? X to the negative 2. You have to use your power. X to the negative 2. The only time you use ln is if you would have had this guy up there. X to the negative 1. Otherwise, they give you points for, can you anti-derive each piece? Even if you're stuck on this one, don't give up. Do the other one. You're going to get some points. Put a plus c in there. You'll get that constant integration point. Be like, I know I'm supposed to use the clue. Make up something. If you can't integrate, you'll lose a point there. But if you use the initial condition in your wrong answer, they'll give you that point. They give you partial credit. If you miss something here, it's not like all of it's wrong. Bridget, go.
I kind of missed what you were saying with the x plus 2 over x. Haven't got there.
The integral of 1 is just x.
Yeah.
Minus, I said don't you dare use ln. You should rewrite this to x to the negative 2 and use power.
2x to the negative 3.
Because then you add a power, be negative 1, divide by a negative 1. They just have it all nice and simplified. So it'd be minus a negative plus 2x to the negative 1 is 2 over x. So think power. Ryan, go ahead.
So like C changes every time you simplify or do something, right? So when you decide to solve for C, you have to go back to where you started immediately, right? Because I got a completely different C because
C
I was somewhere else.
depends on where you find it.
Yeah.
So that's why they don't give you a point for C equaling negative 3, because it depends. Well, do you solve here and get negative 3? I would have probably gotten y by itself, then solved for C, and gotten a different C, but when I simplify, the key is, does it end up being equivalent? It doesn't have to look the same, it has to be equivalent. Does that make sense?
Yeah, because I did what you would have done.
Is that minus 3?
Yeah.
So I would have gotten probably over e cubed or something like that. Does that make more sense?
Yeah. That's what I did.
Yeah, I think I would have thought like 1 over E cubed times blah blah blah.
Yeah, that's
so it would have
exactly
been
what I
C
did.
E to them. Then
Okay.
like plus 1.
But as long as you go back to where you started and you have some C, you're good.
You can either get Y by itself first, then get C, then plug in. Or you can stop, get C, then simplify. Both ways work. Both ways will end up with, as long as you do it correctly, with an appropriate representation. They just use exponent rules and plug in. Yeah. No, I don't think so. I saw this start getting added just last year. It used to be this was all they would even put. Technically, that is only true based on they're using the whole absolute value idea and how sometimes it's going to be a positive C, sometimes it's going to be a negative C, like the way that we would do it, we do B and E and the C tops down. So we took away the absolute values for positive, negative. I don't see them making a point worth that restriction. Because they still have the points split up the same way they used to, aka get Y by itself. But if you guys understand how they're saying, hey, for a positive absolute value, then this is going to be true, you can start stating that. They are trying to get more idea-ish and concept-ish this year, and no one really knows exactly what that's going to look like. But we do have a few practice things we'll do to try to prepare for that more concept-ish approach. We'll see if it comes in. Anything else on FRQs? So, let's go ahead and get to those sample questions. Guys, real quick heads up. And I know, Eileen, I've seen you, I think, with that book, and then I see Bridget with it right now. It's a book we actually used to use. We had an old version, and when our classes were really small in AP Calculus, we would actually let the kids like borrow it and rent them and take them out and whatever, but then they started getting beat up. Whatever practice exams you guys use, whether it's Barron's, whether it's the stuff I've given you online, if it's non-College Board, I just warn you to not focus too much on the free response. If it's non-College Board, I would just say don't focus too much on the free response. Multiple choice can be good in almost anything you look at. Free response, I would urge you, and this is what the kids last year, Stephanie Union did, I don't know how many years of FRQs last year before the actual AP. George Corey's done like 4 years in the last like 4 days. The AP has so many released FRQs. They truly write them like no other. Some try, but they fall short. So my general is if you guys are using some other McGraw-Hill or Barron's or like other study books or Princeton Review or that one, which is a good one. I like that one, the multiple choice practice. Please, please, please just go to College Board for FRQs. Okay, can I go ahead and open up the sample? Brian, go ahead, bud.
On test day, we're going to get a packet that looks just like this, right? And then a packet of paper to write on, or what?
The way you see it on Saturday will be the way it is, but look at your like 1, 2, 3, 4 thingamabob, the 2014. That's what it looks like.
Oh.
It used to be they gave you a blue book and said, here, just write all your stuff, but then they realized that kids don't organize stuff well, so they gave you big old boxes to write
Big old,
with more than enough room as long as you're reasonable as far as. You can technically get scratch paper, I think, if you really, really want to during the AP, but I don't think you guys actually need it. All right, kiddos, this is what I meant by, if I can actually pull it up. The sample free response, which let me show you where it is in your actual folder. Here it is. This was released in 2014. It has been revised for the new stuff. Let's just play around with a few random FRQs from who knows where.
Should we throw this like with our multiple choice stuff?
Yeah, that's what I was thinking. That's why I had you guys get your multiple choice stuff. Random from who knows where, all mixed in. Random from who knows where, in the sense that like they just did some random sample exam questions. And this is a good, short, sweet, not a full-length practice exam. And it gives you the multiple choice answers. It's on your website, and at the end, it gives you the FRQ. I think they give you 2 FRQ practice problems. At the end of the AB portion, it gives you the answer key to it. I'm going to pull up. I used it in BC. I'll just use theirs for you guys right now. First thing you should think, limit problem. Second thing you should think, hey, x is approaching a constant. Third thing you should think, plug it in, plug it in. Fourth thing you should think, good thing I know my unit circle. Should think. This is an example like section 1, part A, no calculator is used. Has anybody figured out what happens when you plug in?
0 over 0, keep going.
0 over 0, keep going. Cosine of pi is -1, sine of pi is 0, 2 pi technically. 0 over 0. Let's do some algebra. Heck no, techno. L'Hopital's. Don't you dare do algebra. There's no factor in there. There's no factor. So what do we do with L'Hopital's? Let's review real quick. You guys were studying your forevers, right? If you get an indeterminate form, what are you allowed to do to the top and to the bottom? Derivative of cosine is negative sine. Ooh, derivative of sine of u. You're going to see that, right? Don't care about it. 2 cosine 2x. Derivative of 1 is 0. Why didn't I write 2 pi?
It's probably constant.
Plug it in, plug it in. Maybe sine of pi plus 2 cosine of 2 pi. All over 2 pi. Sine of pi is 0. Cosine of 2 pi is 1. The 2 over 2 pi reduces to be. Look at those 4 answer choices. Got it? Down below it just says, hey, we're showing you how to do L'Hopital's. You're like, great, thanks. I should have figured that out on my own. Let me have them play with another one. Katrina, go ahead. You're doing high, but 2 pi would be back in the 0. Should have been 1 over pi. The 2 over 2 reduces. You guys should have seen a limit, seen it going to infinity. Said degree tests. Degree tests. Who wins? Top? No.
No. Both.
Tie. Square root of x to the 4th is x squared. 9. No.
That gets
Square root of. Essential knowledge.
Yeah.
Look at you. You're in every single question.
Yeah.
Square root of 9 over 1. So the answer's 3. Beware though, if that was a negative infinity, we should always with infinite check the sign, but that's a positive, that's a positive. I know, we're almost done. You guys see how there's some really good ones in the sample repeat thing? Online? Okay. Pause, I know. You guys like those. That's a calculator. Calculator. What are you going to do if you see words?
A lot of stuff.
Collapse.
You're going to breathe,
Fahrenheit or China?
and then you're going to think. You're going to breathe, and then you're going to think. Now, this is a multiple choice. In workshop a multiple choice, the answer is yes. This is then maybe getting a little more concept issue. H is temperature. H prime. H is temperature. H prime. What should H prime be measured in? Or what is H prime?
Fahrenheit
It's
for
the
something.
differential
Rate.
of time.
Yeah. Rate. Well, it's not that one. The rest of them say something like increases, increasing, increasing. Wait, ooh, I like the increasing ones. Which one makes sense?
We'll see.
2/5? Where'd you get 2/5? Isn't the rate 2 at 5?
Yeah.
Isn't the rate 2? Why increasing? What sign does it have? Positive. You sound so smart. Look at you. Kiddos, yeah, there are some wordy, there's still multiple choice. Look at all these. Now, pause. Get a couple of free response. Kiddos, during lunch I'm having, anyone who did not take the forever quest yesterday, try had to be early. Anyone from grade 1, if you weren't here yesterday, be here at lunch right at the beginning, grab your food and run. You're taking your forever quest during the time that has elapsed. So lunchtime time, good time to know your questions answered after school. I will be here for a while. Bye guys. We might do more questions in period 6. If so, I'll save their document and put it online if you want to see it. Under class notes. Bye guys.
I asked you.